I'm Mike Huffman, and this presentation will focus on climate change and its impact on water, one of the prime elements responsible for life on Earth. Let's put water in perspective. Just how much water do we have? 97% of the water on the planet occurs in the oceans as saltwater, and it's not readily available to us. Only 3% is fresh, and of that, 99.7% occurs as ice caps, glaciers, or groundwater. The remaining 0.3% occurs as surface water, lakes, swamps, and rivers. In one way or another, nearly all the sources of water that we depend on are being affected by our changing climate. Climate change is bringing about significant changes in the water cycle. The warmer climate causes more evaporation of water from the land and the oceans, and a warmer atmosphere holds more water. In fact, about 4% more water for every 1 degree rise in temperature. And since we have gained about 2 degrees through climate change, we have 8% more moisture in the atmosphere. That's a lot of water. These changes are expected to lead to specific and, in many cases, negative consequences affecting the amount, timing, distribution, form, and quality of water. Let's start by looking at the changes in the amount and timing of precipitation. For example, in the Northeast, the total average annual precipitation has increased about 5 inches since the late 1800s, a shift towards more precipitation. Also in the Northeast, over the last 30 or 40 years, the area has experienced a 72% increase in downpours, or what are called heavy precipitation events. These are defined as being those events in the top 1% of all daily precipitation events. This results in increased risk of floods, erosion, runoff of nutrients, risk to infrastructure such as road and rail systems, and much more. And this trend is expected to continue and intensify along with more intermittent droughts. Overall, more extremes, too much or not enough water. On a global scale, wet areas will get wetter, dry areas drier. Now let's look to the future. We're looking at projections toward the ends of the century. And look for the Northeast. You will see that in general, we are going to get an increase in precipitation towards the end of the century between the winter and spring. In the summer and fall, those changes will be more or less like they currently are, but a little bit drier in the summer. But then look to the southwest and the west, much drier towards the end of the century, which has huge implications for agriculture and the millions of people who live there. There's also a 99% chance that the southwest will experience a megadrought before the end of the century. That's a 35-year drought. Now let's look at changes in the form of water. What we see here is a shift from snow to rain during winter months over the years 1949 to 2015. There's a strong trend towards more rain. The larger the red dot, the greater the shift to rain. And this trend is expected to continue into the future. Less snow overall, more rain. In areas depending on gradual snow melt of snowpack to supply water during the summer months, this puts additional stress on the whole system, a trend we're already seeing in the West. But there's more. Let's look at another shift in form. Glaciers are melting, turning from a solid to a liquid, and that's critically important to irrigation in many parts of the world, as well as hydroelectric power. In some South American countries, the majority of the water for their hydroelectric systems comes from summer melting of glaciers, but the glaciers are disappearing. And lastly, with more turbulence and moisture in the air, we will be experiencing more hailstorms. Now let's look at water quality. What will happen with climate change? Warmer air temperatures will result in warmer streams, lakes, and reservoirs, and this clearly will affect species of fish, like the trout. Its distribution will change because it prefers cold water. When water warms, it also holds less dissolved oxygen, negatively affecting fish, insects, crustaceans, and other aquatic animals that rely on that oxygen. Warming, in combination with increased runoff of nutrients from land due to the increased downpours we're experiencing, results in algal blooms. Harmful algal blooms, especially as like ones shown in Lake Erie, are going to become more common. And now let's turn to the oceans. They hold 97% of the planet's water. Sea levels are rising due to thermal expansion. Warm water takes up more space. And also, contributing to this are the melting of ice caps and glaciers. So far, sea level has risen about 8 inches, but even that small amount had a great impact on storm surges associated with Hurricane Sandy. The water was just simply that much higher coming inland, and that made a huge impact. Sea level rise, which is predicted to be as much as 6 feet by the end of the century, will have enormous economic, environmental, and social impacts worldwide, including the displacement of millions of people living in coastal areas. The impact on Miami is shown here. So can we simply pump more water from the ground to offset the loss in precipitation in certain areas where it might be needed? Let's say in the Great Plains? Although the impacts of climate change on groundwater are not completely understood, rising water competition and stress at the surface is likely to increase demands on this amazing resource. One consequence of overuse of groundwater is land subsidence, as has occurred in California, where it has reached 28 feet in some places. And large aquifers, the Ogallala, the single greatest source of groundwater in North America, which helps provide irrigation water to the Great Plains states, where 1/6 of the world's grains are produced, that aquifer is greatly overdrawn and not being replenished. So no, we can't turn to groundwater as a way to address the distribution of water. Take-home message: climate change will have wide-ranging impacts on our water resources, including the quality of our drinking water, agriculture, food security, energy production, recreational activities, infrastructure, forest fires, and much, much more. All the more reason to reduce our greenhouse gas emissions as soon as possible.